Now we will talk about the superposition principle. Superposition means what? So suppose there is a wave that is coming from source 1. There is another wave that is coming from source 2. The resultant is the superposition says the resultant is the sum of the individual contribution from the individual wave. So if there is a source 1 and a light ray is coming, which is going to give you electric field at a point P, which is E1, this one, and suppose another light ray is coming which is going to give you a electric field at that point E2. Now suppose the only source 1 is present, then the electric field at that point will of course be E1, and if only the source 2 is present, then the electric field will be E2. Now if both of the sources present, then the electric field will be E, which is equals to E1 plus E2. Fine. Now suppose E1 is A1 sine omega t and E2 is A2 sine omega t plus delta. Now delta, now A1 and A2, the amplitudes can be different, can be same. Now delta is the phase between the two wave. Now if delta is constant, then they are called coherent source. And if delta randomly changes with time, then it is called the incoherent source. So these two definitions are very important, mainly the definition of the coherent source. So only in the case of coherent source we can going to see a interference pattern. For incoherent source, there will be a pattern, interference pattern, but that is going to change so rapidly with time. What we are going to see is an averaged out intensity. That means we cannot see any interference pattern. Now, what will be the resultant amplitude? So E will be equals to E1 plus E2. Now there are some derivations which are there's some algebra which are important, that the derivations might come, but I'm going to write the formula at the end. So I will be intensity will be I1 plus I2 plus 2 root over I1 I2 cos delta. This delta was the phase difference. So what where do I get it from? So basically E will be equals to E1 is A1 sine omega t plus E2 is equals to A2 sine omega t plus delta. Now we will need to simplify this, and we need to use the formula that intensity is proportional to amplitude square. So this is basically, this one is root over a1, sorry, this one is a1 square, this one is basically a1 square, this one is a2 square, this one is a1, this one is a2. So here it is just being vectorially added, and this is the resultant amplitude A. So you can remember this. Now if I1 equals to I2, and which is suppose equals to some I naught, then I can just put everywhere I naught, and the formula that I am going to get of the resultant amplitude is I equals to 4 I naught cos square delta by 2. Now which means that this cos square delta by 2, delta can be anything, it will be constant, but it can be anything. So if it is 0, 2 pi, 4 pi, etc., or basically 2n pi, then we are going to get the maximum intensity. This is the maximum intensity, which is 4i naught. And if delta equals to pi, 3 pi, 5 pi, etc., that means 2n plus 1 into pi, then I am going to get this, it will be pi by 2 here, and pi by 2 means cos pi by 2 is 0, so I'm going to get I equals to 0. Okay, so this is called the destructive interference. Now what is interference? I have said interference is basically the superposition of two coherent sources, superposition of light from two coherent sources. Now, the one that is in our syllabus is Young's double slit experiment. So, I'm not going to prove it or derive any formula, but you have basically a wall, and in the wall there are two small holes, and there's a light source coming. So, this part is not important in the sense. What is important is there is a source of light S1 here, there is a source of light S2 here. Each point, or this is because this is a point source, light is going to go in every direction. If I take two random direction, for example this and this, random rays for a point P, then there will be a, these two have a phase difference. What the phase difference will depend on? The phase difference will depend on the path difference between the two light rays. This is the path difference, delta. So the relation between the phase and the path difference is this. So delta equals to delta by lambda is equals to phase difference. Phase difference I'm writing as delta by 2 pi. So I can find out delta from here, which is 2 pi by lambda into the path difference. So this is the path difference. Okay. So you can understand that if the path difference is lambda, 2 lambda, 3 lambda, etc., or n lambda, then we are going to get a constructive interference. And if the path difference is odd multiple of lambda by 2, then we are going to get a destructive interference. And what will be the intensity? Intensity formula we have already got, cos squared delta by 2. So intensity will be something like this. Sorry. Okay, fine. What is diffraction? Diffraction is superposition of multiple coherent sources, or you can define the diffraction in another way. It is the bending of light when it encounters an obstacle. So light ray is coming from infinity, and suppose parallel light ray is coming. Now every point on this wavefront, this is a wavefront and this is a hole. They are going to behave like point sources. So these are the many point sources that we are talking about, and from these point sources light ray will go, and there will be a lens, and they will be collected at this point, and they give rise to a diffraction pattern, and the diffraction pattern looks like this. This is called the central maxima, and this will be the first maxima, then the second maxima, maximum, so forth. Okay. Now, what is the difference between interference and diffraction? So interference is between two coherent sources. For diffraction, multiple coherent sources is required. So for interference, intensity maximum, all the intensity maxima have the same magnitude. So all of them have the same equal height. Okay, so they have all the same magnitude. For diffraction, the intensity maximum is decreasing. So intensity maximum is decreasing like this. Okay, on this side and on this side. And 3, is all fringes have the same width. What is the width of the fringe? These are called the fringe. So this is the bright fringe. This is a dark fringe. Okay. So this is a bright fringe and this is a dark fringe. So all of this fringe width or width of the fringe is same. For diffraction, the central maxima has the maximum fringe width compared to this maxima, and of course compared to the minima. Okay, so hopefully this is also important, the difference between interference and diffraction. So all the fringes have the same width in the case of interference, and all the fringes have different width. Not all the fringes. The central maxima has the maximum width compared to the other fringes, and central maximum has double the fringe width compared to the first or second or third maxima. Okay. So there are other questions also that is possible from this part, but I'm not going to go in there right now. So if you can look at the CPQ questions from the either G20 model paper or the KV Shankartan study material, and you can find out other questions. And if there's any problem, please